Hi everyone, I'm Kho Verian. I'm a scientist at LATICRETE International and I've been with the company for more than 2 years. I will present our work in the area of 3D construction printing. So LATICRETE was founded in 1956 in Connecticut and has been a leader in tile and stone installation materials. Some of our groundbreaking innovations include the first load-bearing acoustic underlayment system, the first cement-based epoxy resin, and the first liquid applied waterproofing membrane, and many other more. Since 1960s, LATICRETE has been involved with many major global projects, including the first World Trade Center in New York City, Sears Tower in Chicago, Petronas Twin Towers in Kuala Lumpur, Malaysia, Burj Khalifa Tower in Dubai, and many other more. We have been working in the area of 3D printing since 2018, and we have done several 3D printing projects. And currently, we are one of the voting members of ACI Committee 564, which is the committee which addresses the application of 3D printing with cementitious materials. In this presentation, we will discuss the area of 3D construction printing, several techniques of general 3D printing, and the types of construction 3D printers. Moreover, we will share some of our thoughts on some key aspects in construction 3D printing which need to be considered during the project. The design aspect in formulating 3D printing material and further scaling it up from lab scale to construction are also be part of this session. So first, let's talk about what is 3D printing. In the construction area, 3D printing is basically a process of building object or structure by using 3D printer from a computerized model, 3D model. So we use computer to generate the 3D model. You can use AutoCAD or other 3D software. And then the 3D model then slice using slicing softwares. And by slicing the 3D model, we will generate what we call a G-code. The G-code is the input code, which is used as the input command for the delivery system. The delivery system usually consists of the printer and also mixer and pump. So usually the materials are mixed in the mixer and then pumped through the hose and then through the extruder at the extruder head, which is mounted in the printer. As the result, the printed structure. And again, all of these are controlled by using a simple computer. So why is 3D printing gaining its popularity in the construction area? First of all, this method is proven to be more efficient than the conventional method. It can reduce the manpower significantly, creating a safer working environment also as the result of the reduction of number of people need to work. Moreover, this technique enables faster construction as compared to the conventional method. Moreover, 3D printing enables us to have a more sustainable construction in which we can build with less materials by optimizing the printing. We can see here on the left side, those are the precast stairs as compared to the 3D printed stairs, in which in 3D printed, you can see that some area of hollows, which are the materials are needed, without compromising the structural integrity and also the functionality of the structure. Now, formwork also is needed in 3D printing as compared to formwork, which is costs 20 to 60% of the overall construction costs. Furthermore, 3D printing has generally higher degree of freedom as compared to the conventional construction method. As the result, we can print complex design. For example, here is a spiral tower with 5 degrees of rotation per layer, which is printed within less than 5 minutes. Now compare with the traditional method in which that for creating such a spiraling tower, we may need a special formwork. In the picture as well, this is a structure, concrete pavilion, which consists of multiple printed concrete panels. I will talk more about this project later. And the other one is the test print, which shows that we can print curves easily without the need of formworks. So with the benefits that 3D construction printing has, it's potentially can be a solution to provide affordable housing for the community across the globe. For examples are the project by New Story and Icon in Mexico, and also 3D printing restroom project in India. The 3D printed structure also potentially more resistant toward fire, as we can design the material accordingly. This can address the fire hazard problem in the area which are prone to wildfire, as we know that recently some of the areas like California and Australia were hit by the wildfire, which burned down many houses, leaving families losing their houses. 3D printing also can be used to build temporary shelter for refugees at the area hit by disasters. Moreover, in military application, 3D construction printing can be applied in building barracks, shelters in a more efficient fashion than the conventional method. So as seen here are the huts printed by the US Army Corps of Engineering using 3D printing method. So 3D printing is the future of construction. In the future, the robotic 3D printing has the potential to be used in building human settlement on the other places outside Earth. For those of you who are familiar with Star Trek, so probably before we send Captain Kirk and his Starfleet crews to explore the space, we might find ourselves sending robots to explore and build some settlements on the other celestial's body. There are several known 3D printing techniques. The first one is slip forming. It is known to be the oldest form of 3D printing and is still popular until now. In slip forming, the formwork is adjustable or movable to form the structure section by section, mostly for horizontal structures like pavement and curve. For vertical application, the formwork can be moved vertically step by step. The second one is binder jetting, in which the binder is selectively deposited onto the powder bed. The binder bonds this area together to form the solid part. Once the object or building is completed, the powder is removed, leaving the printed structure. The third method is known as stereolithography, which is used mostly on resin. The printing involves a photochemical process by which a photosensitive polymer is cured with light. The last one is through layer-by-layer extrusion. In this process, the structure is built layer by layer from the bottom to the top. In this presentation, I will present mostly our work in 3D printing using layer-by-layer extrusion method. In addition to different 3D printing techniques, let's discuss about the type of 3D construction printer. 3D construction printer usually has larger printing area as compared to desktop 3D printer, as it is intended to print structure components. The first 3D printer that I would like to present here is the robotic arm. Robotic arm 3D printer usually has multiple rotational axes, which enable them to print not only in horizontal plane, but also print in diagonal planes. The second one is the gantry type 3D printer. The gantry type 3D printer usually consists of frames. Each frame consists of columns which support several beams. The extruder head is usually mounted on its horizontal beams. The size of this printer can be adjusted by adjusting the number of columns and the beams. The third 3D printer is Delta 3D printer. Similar to the gantry 3D printer, the size of the printing area of the Delta 3D printer can be adjusted by extending the size of its frames. The difference is that in Delta 3D printer, the printer head is supported by 3 arms. Each arm can move independently in a vertical manner. By synchronizing the movement of these 3 arms, one can move the printer freely within the printing area of this Delta 3D printer. The fourth one is the crank type 3D printer. The crank type 3D printer usually consists of one tower which support a cantilever arm, in which the extruder is mounted at the tip of the cantilever arm. The cantilever arm can be extended into a certain degree to increase the printing size, to increase the printing area of this printer. Similarly with its column. The column usually, the height of the column or the tower is usually can be adjusted. The fifth but not the least is known as a SkyBAM, big area additive manufacturing developed by Oak Ridge National Lab. So, the printing head of the SkyBAM is usually supported by multiple cables. This can be seen in the picture. One cable supported the printer head horizontally, while the other cables supporting it at different planes. By adjusting the movement of all the cables, one can move the printer head easily. Usually, the printing space of SkyBAM can be very huge. The system of SkyBAM is the same to that of SkyCam. So after conducting several field trials and printing projects, which will be presented later, I came up with several key parameters that are important in the work of 3D printing. First is the materials. The material should be workable and printable, which means it can be pumped, extruded, and hold its shape after being deposited from the printing head. The material should have enough open time to accommodate the capacity of the delivery system, which usually consists of the pump and printer. Once it is cured, the material should possess sufficient mechanical properties so that it meets the requirements set by the building code, if any, for its extended application. For example, if the printed element is designed as a long load-bearing beam, then the material should meet the strength requirement for that specific load-bearing beam at that specific structure. Moreover, the material should be designed to be durable. For example, able to withstand long and repeated exposure of extreme weather. For the delivery system, the pump and printer should be able to accommodate the materials used for printing. In addition to the materials and delivery system, how to manage the printing work is also part of the equation for the success of 3D printing. How fast is the print, the sequence of printing, where to locate the pump, the hose, and many other management related works. Another aspect that needs to be considered during the printing is the environment. So printing at different environment might affect the properties of the materials used. For example, when printing in a hot area or during the summer outdoor, the materials might be cured faster as compared to when we print at the cold area or during wintry season. The environment is especially need to be considered when we do the print not in a well-controlled environment. Moreover, is the structural design. So the structure itself should be designed, should be well designed, safe and sound, and stable structurally. The last but not the least is the team who will carry on the work. So the team which manage the work is very crucial in the success of the work. The well-trained team which know how to troubleshoot when unexpected trouble occurs is much better than a team without experience. And the team also should remember to update the computer software just in case, so that the work won't be interrupted by software updates. Now let me discuss about the design aspect of our 3D printing materials. So at LATICRETE, we carefully design our materials to assure that we only produce the best quality of materials. Our 3D motors are designed to be printable, easy to use, and adapt to various types of 3D printers, pump, and environment. We can design the material accordingly to satisfy and surpass the requirement of the project. For example, we can design various level of strength materials with various level of strength. In addition to that, we also design our material to be durable so that it can last long and it can stand still during the surface life of the structure. Moreover, our team also design our material in an innovative way, in which we have designed several formulas which have lightweight, normal weight, different colors and textures. And overall, our products are also cost competitive while also maintaining its quality. Now, I will discuss about our work in the lab. So I still remember that the first week of my study at Purdue University for my grad school, my professor sent me many papers related to my project. And the environment and the information provided in those papers really helpful in giving me the knowledge that is needed for the project. So here I am, applying what I've learned from him. So first, the research is started by gathering information through literature review, attending lectures or presentation conferences. By that, get information related to the behavior of the materials. So we move further. Using that information, we start with the formulation. We move to formulation, in which the formulation later on was tested by lab scale tests, in which we tested for the fresh properties of the materials and also the printability by printing a miniature structure, small scale structure. This is approximately only 4 to 5 inches tall in our lab. And furthermore, we assess the mechanical properties of our materials like strength, compressive, tensile, flexural. We also assess the durability properties of our materials to again ensure the quality of our materials in long run. Moreover, in the lab, we develop a new test to assess the tensile adhesion between layers. Especially, we would like to pay attention to the cold joint. So the cold joint is a plan of weakness in concrete which caused by interruption or delay in the printing process. It occurs when the first batch of concrete has begun to set before the next batch is printed on the top of the first batch. so that the two batches do not intermix. For example, here, the printed section, the lower part, which is printed on the first day, and then we stop the printing, and we continue the printing of the upper part the next day, causing the interlayer here become the cold joint. So in our lab, we treated and we untreat the cold joint, in which for treating the cold joint, we applied some adhesive prior to the printing of the upper part. So we tested normal weight and also lightweight materials. Can be seen here that the interlayer addition increase along interlayer addition strength increase along with the edge of the specimens, and also treating the cold joint reduce the possibility for having the structure fail at the cold joint. So you can see it here. So in addition to developing a tensile addition test, we were also experimenting on curing the material faster by injecting accelerant in the material channel and then mix the material with the accelerator by using static mixer, with the hope that once the mixture is extruded, the material will get hardened faster. This method is proven to have the potential in reducing the deformation of the printed structure. You can see here that the materials without accelerant deform more significantly than the materials with accelerant. Furthermore, however, with this method, it increased the complexity of the system, also increasing the price. This method, however, will enable us to use less viscous material, which obviously will reduce the potential clogging on the pump and also on the hose. Moreover, we also tested section of our printed structures to its compatibility to adhesive, considering that when we print walls, we would like to apply some finishing surface or even install some tiles on the printed walls. So two different cementitious adhesives were evaluated for the bonding compatibility with the 3D slabs. The test results indicate that the bonding between the printed slab and the adhesive meet the requirement for tensile adhesion, following the EN standard specification. None of the failures were occurred at the interlayer of the slab and the adhesive. Can be seen in this picture here. Furthermore, we also test the compatibility of our printed structure with coding. So the printed slab, it can be seen from the pictures, two specimens were tested. One is coated with coarse putty and finished with fine wall putty. The second one is coated with cement plaster and also finished with the fine wall putty. So again, the specimens were tested to tensile tests. The failure planes occur within the coarse putty or plaster. So cohesive failures within the base coat matrix is an indication that the adhesion between the 3D printed slab and the base coat is very strong. The test results satisfy the requirement for tensile adhesion test based on the EN 1015. These tests were conducted by our team in India. Moreover, if you can take a look here, the thickness of the finishing surface is also being affected by the smoothness of the surface of the printed slab. So after conducting such extensive lab works, we conducted several field trials as well. In North America, we printed several medium-sized structures with different partners. First one is with Crane. Second one is with Ball State University. And the third structure here is printed by the Twente in Canada. We also tested our materials in Europe. And as to the results, our materials has been tested with various types of 3D printers and by various teams. We conducted the test as well in Middle East and India. So it can be seen here. This is the test we conducted with 3D Vinci, and with their help, we are able to understand better about our materials. In India, we collaborated with Hamilton Lab, a 3D printing company based in Singapore, for the restroom 3D printed restroom project. So from the field trials, we finally scale up to construction projects. So far, we've done 2 large-scale printing projects. One is DE Stress. It's a 3D printing concrete pavilion designed by Dr. Christopher Battaglia, which was part of Columbus Exhibit 2019 in Indiana. The pavilion consists of 110 printed panels. Each panel is unique and is designed to interlock once all are put together, so all panels are in compression. The second project that we have done is the 3D printed villa or house in Dubai. We have this project. We collaborated this project with 3D Vinci, and we supplied the material, but also our team were there to help with the work on the materials and the printing process itself. So we have several ongoing 3D printing projects, and as we can see that all of our projects are done not by ourselves. We have partners in most of the projects, and we are open to collaboration in this area, so that together we can move forward in improving this technology and bring the benefits to the society. From our work, we also managed to have multiple publications, and we are fortunate enough to share our work in several occasions. And feel free to contact me or Matt Carley, in which if you would like to read more about our work. In addition to the publications, and these are the references that I use in this presentation. And finally, we are at the end of this presentation. Thank you for your attention, and I hope the information shared in this presentation can benefit all of us. For questions, please contact myself or Matt Carley, as our emails are shown in the slide below. Thank you.